David Rowen is editor of Wired UK, which won the 2009 Launch of the Year at the British Society of Magazine Editors Award. He has edited many, many different things. He's edited The Guardian websites, he's written tech and trend-watching columns for The Times, made TV films for Channel 4 News, and produced lots of features for The Telegraph magazine, The Sunday Times magazine, The Observer, and also elsewhere. Trained at The Times, he edited The Guardian's op-ed education, analysis and Saturday feature section, and most recently has also edited The Jewish Chronicle. He'll be presenting a panel together with Hal Bertram, and we're very thankful for this incredible dialogue we've had actually with David over the last couple of months. His magazine is a real laboratory, very much as earlier I mentioned Bruno Latour, when Bruno Latour talks about this idea of maps being a laboratory of the 21st century. Wired has permanently new maps, and we discussed with David that it could be interesting because a marathon always hides another marathon. We feel to make this format not so monolithical, we like also to invite speakers, to invite other speakers. So we invited David to make a session, and he proposed to invite Hal Bertram, and they will be presenting together a panel here on the topic of data visualization. A very warm welcome to David Rowen and Hal Bertram.
Thank you, Hans-Ulrich and Julia and everybody at the Serpentine and the RGS for an awesome couple of days of programming. So, I edit Wired magazine, and I get excited about raw data. Now, before you think this is the moment to go off and have that coffee, we're going to talk about how, with a bit of creative visualization, you can turn raw data into visualizations that not just cut the commuting time you have, not just understand the external world, but can save lives. But before I introduce Hal, who is a master at this, I just want to give you one figure that I heard recently from Eric Schmidt, the Google boss, who said, in the whole of human civilization up to about 2003, collectively we generated 5 exabytes of data. That's 5 billion gigs. Now we're generating 5 exabytes every 2 days, and the pace is accelerating. And that's everything from watching video online, instant messaging, swapping huge files. And with all this data out there, we have to turn it into information if we're going to use it. So mapping very, very smart visualizations is probably the most effective way to do that. And I'm delighted to introduce Hal Bertram, who works for a company called Ito as Chief Technology Officer. Now, Ito, we've partnered with a few times in Wired because they are at the cutting edge of taking these raw data feeds and turning them into moving images, still images, ways to understand it that make sense. So Hal, I would like you to start by showing the most effective ways of using data, maybe to save human lives.
Okay, well, let's have a look at what the Openstreetmap project did in Haiti.
So the earthquake hit Haiti in January, and there wasn't much data in terms of what the rescue workers could use to go and rescue people. So this was when?
This is an image of Openstreetmap, which is a collaborative mapping project, similar to the way Wikipedia is building an encyclopedia. Openstreetmap builds a map of the world. And this is the amount of data they had before the earthquake.
So if you're a rescue worker, you're trying to go into the back streets of Port-au-Prince, there's no ordnance survey there. You have very little to go on.
There's very little to go on.
So then this collaborative community, I think there's about 250,000 people in about 30 countries. They got together and they took raw data, satellite data from Google, from other people, and show us what they did.
The great thing with Openstreetmap is because people can edit it any time. It can really respond dynamically. So these people were editing it from aerial photography, and all the major aerial photography suppliers donated all their imagery for the area, which was very useful. So this is afterwards, and you can see it's been completely filled out. And we've got a little animation to show how that process happened. And you'll see from the event, people were starting to map within about 8 hours, and that was people in Europe deciding that it would be useful to contribute to this map. And they just sat with their laptop, pulled up some aerial photography and started entering the data on the map.
Have gone now, their homes have been destroyed. And the rescue workers who used these open maps, they said this helped them save lives.
Yes, every night they could load a new updated map into their navigation devices, and it was a huge help.
But Openstreetmap isn't just about emergencies when there's a natural disaster. I mean, explain how this open source network of volunteers is helping day-to-day life.
The main thing about mapping is it's very useful to be able to get the raw data at the end of the day. If you use one of the commercial suppliers, I mean, sort of Google Maps, for instance, you can only use their rendered images, and they have an increasing number of styles, but there's not really much you can do with it. Openstreetmap is about openness and being able to contribute to this map, and also being able to draw down the source data for your own use. One of the things we sort of look at is how providing visualization to help the people creating this map create the map better. And one of the things that's very interesting to see on a map is how recently each area has been edited. And so on this map of London, you can see there's an area here that's been edited very recently, and that's someone adding building outlines to an area. A lot of people map in their neighborhood, and once they've mapped all their roads, they tend to sort of go and map buildings, and if they're obsessive, they can then go on and map post boxes and all sorts of details. It's amazing what's in this database. You can see for each country the degree of mapping. Generally, the white bits, which are the most recently and edited, are all in the cities. Here's the States. This large wash of colour is because most of the roads on this map were imported in bulk, well, sort of state by state. But then the bright bits are where people have taken over and have started editing stuff based on their local knowledge. And then this is the Bay Area. And some of these this presentation of it is great because it takes away what you know about the mapping and just leaves these sort of fairly abstract images of how the network's joined together. And this is a very large image just to see how I can, just to see the whole of Europe and the edits. And what it reveals is that Germans are very frantic mappers.
If anybody knows anybody in Albania or Serbia, we need a bit more help. Show us the visualization of the world, which is the most exciting one.
Well, if we start with, as well as showing these stills, we can look at animations of them. So this will show London in a sec. This is how London got built in Openstreetmap. You see people starting off.
So this is about 4 years ago.
Yeah, this is the course of 4 years' work. You'll see that initially it's about filling in the blanks. And each one of these flashes is someone having done half a day's work and pressing submit, and it going into the main database.
And can I just say this helped me get here today, because I downloaded an app called Forever Map last week, which is 2.2 gigs of information, but it's a map from Openstreetmap of Europe. And when you're underground trying to get to places, you don't have the internet. But I managed to find out the quickest route here by looking up which road in Kensington was the quickest route here.
So taking this onto a planetary scale, we produced this animation of a similar thing showing all the edits going into the worldwide database. And this was very useful, and it was great as a sort of advocacy for the project, that people who could easily just send people this video and say, well, this is what I do in my spare time. It also shows a lot about the density of coverage in different areas and which areas are active and which are increasing.
This is why we call it info porn. It's just exciting imagery. But you've also touched my life more recently. So I was stranded in Moscow in April when you may remember an Icelandic volcano caused a bit of trouble in the air. And I didn't know how I could get out of Moscow, so every day for about 4 or 5 days, I went to a website that showed the database of an organization called Flight Radar 24, which again are volunteers all around the world who track UHF signals given from commercial aircraft, and then that information is mapped. Each of these yellow things is an aircraft, each of the blue crosses is an airport, and so in real time you can see where the flights are. So Hal, explain how you could tell which countries were dark and which countries were active.
Well, we saw this this website was aggregating all this information, and we wanted to show how the flight system came back to life after the volcanoes. So we put a tracker on this feed from this website, and we produced an animation of it. In it, you'll see there are certain areas that are dark where they don't have sensors.
So if I wanted to get to Spain, I was in trouble, but maybe I could get to a bit of northern Italy.
So this is one day in. There's really very much, almost nothing in.
So this is, we're looking at about 5 days worth of flight traffic in April at the peak of the ash disruption. You're also measuring CO2 emissions over Europe, so this was pretty good for the environment.
Europe had a break for a while, yeah.
So now things are starting to get back to normal.
And here you'll see up in England, sort of in the UK, you'll see the test flights the airlines were running in just a sec. These little things will spin around. There you go. And this really also, as well as showing how it restarted, just shows the sheer volume of data, sheer volume of traffic flying over Europe all the time. This is what it looks like every day now.
So does that mean Spain was late, or there wasn't just very much data?
There's no data in Spain. There's another website that does.
So Heathrow, I think, is a pretty busy airport from this. So this actually did help me get home, because I managed to get a flight to Rome, because I saw that, for a moment, that part of Italy was open. You do quite a lot of work with public transport data. You're an agency that works partly processing data, but also visualizing data. Tell us the sorts of work you've been doing in places like London.
London's got a lot of transport, public transport. You can obviously see it out on the streets. Visualizing it provides a way to... You're very familiar with what's just around you. You know your neighbourhood and you know the routes, and you know roughly how many vehicles. It's very hard to scale that up and see what's going on in the city. We work with the DFT, looking at the data sets of the national public transport, and we visualise it. There are some ways in which these are all the spot of light is a bus on a Wednesday morning. First thing you realise is there is a lot of it, and it kind of explains why Oxford Street is a wall of red every morning.
So we should clarify, this is based on the schedules. We're not tracking individual buses.
Yeah, this is where they no, you're right. This is where they should be on a Wednesday morning.
And I think some of the buses going at 300 miles an hour, that's an aberration in the schedule, is it?
Yeah, that's useful to us because it points out where data's wrong. In your way, your eye is very good at picking out the wrong stuff as well as the right.
Although I think I have cycled behind some of those buses going at 300 miles an hour. So how can we use this?
Well, so here's another visualization of the buses in London. This is showing the density of bus journeys on each piece of road in the capital. It's very useful to see where obviously the main corridors are, and it has a very nice organic feel of these main sort of arteries.
So there is a real world use in that if you're planning a journey, say to Croydon, which is that big high rise at the south, you can notice that there is a very, very main busy bus route. Yeah. But if you're trying to go to other bits of Surrey, you may be stuffed.
And if, alternatively, you can use it as an end user or as if you work with the transport network, it's very useful to be able to see which areas are covered or well provided and which are not. And in the country as a whole, it gets far bleaker as you go further out. This is just showing you that those were buses. This is showing all the modes of transport in London. So I'll just zoom in here for a sec. So we've got trains in white, the tube in red, buses in blue, and the coaches in yellow. If we run this, see, this is what goes on all the time.
And this is data from where?
This is data from the National Data Repository. Every October, a complete snapshot of the country's transport information is compiled. It's historical, and there's a general shift to making these things available.
And are we going to get to a stage where, in real time, we'll be able to see through our mobile phones where the traffic is, how fast the trains are running?
I think almost certainly. I mean, it's coming. I think the companies that hold the keys to this data are realizing that if they free it up, then people will produce all sorts of apps and ways of effectively driving traffic to their driving customers to their vehicles. So,
just like with the Boris bikes, there's an awful lot of apps now where you can track the data, see where the bikes are in real time.
Yes, it's a very modern way of doing that. That rather than trying to produce websites that would handle it all, they just supply the data feed and let everyone else do it, and it's quite a cost-effective way as far as a government department is concerned.
So we are having a bit of a battle to try and persuade these authorities to release this data. So there's been a group within the GLA that's been working with the Mayor's office to create the London Data Store, to create open feeds, and that's had an extraordinary impact. They released quite recently the feeds of real-time underground train movements, and a coder called Matthew Somerville took this raw data, put it online, so you could see on a map where the Piccadilly line trains were, how staggered they were, and I think the site collapsed because 10 million people were accessing it within a few days.
Yeah, they completely underestimated
which shows
how
there's demand.
Interested people were, yeah. And they need systems, and they're developing systems to protect them from those sort of overloads. But the demand is there. If you provide the feed, you'll get a surprising number of people using it.
So I think we need to push the people who are resisting releasing this data, and I won't mention names, but National Rail is on my mind, who are trying to charge money for a £5 app, but we're taxpayers subsidising the Association of Train Operating Companies. So it makes complete sense that we have access to this data, so collectively, the visualisers among us, the coders among us, can try and create something useful that helps you understand where trains are, helps you plan your journey. So before we get mired in politics, I just want to talk about, it's not just within the UK, it's around the UK. There's a marine traffic map. You're getting a sneak preview because we're going to do this in our magazine Wired next month. But explain this.
Well, this is another map of the world. Similar to the aircraft, there's a similar facility for vessels to report their positions. In the same way that the aircraft aren't tracked over the Atlantic, in the open seas there's no information. But so what you get is you get this straight line jumps where there's no information, but you can see the vessels going around Europe here, and whenever they get close to the coast where there are receivers, you get the sort of detail built up at the lowest level.
So we should point out that this is not a drawn map of the coast of Britain. This is only movements of marine craft, which by itself draws the map.
Yeah.
And you can see how busy the English Channel is. You can see the Holyhead Dublin route. I mean, to me that's art, but it's also quite useful because it's real data.
Do you want to have a look at the flights over Europe, looking back at this network here, this one. This is looking at taking this to be more of a network where the ascending flights are in red and the descending ones are in blue. And the things like the marine traffic and this show networks that people don't really know exist. They kind of, obviously you look up and you see planes and you suspect there's an organisation of where they go, but you don't never really see how they do move around. But you see the density shown here, and obviously London's very dense. Got another slide showing London here. This is what we're sitting underneath. And in blue, you can see the stacking towers and the takeoff patterns. And obviously, planes have another dimension, so this is, in fact, we can animate this and have a look at how this really works in space. And you see here the 5 London airports. City is obviously very small. The blue has a very simple approach pattern. It's very reassuring how approaches all seem to come down exactly the same line. Takeoffs are a bit more chaotic, but I think that's because once the plane is up and safe, it's pretty much free to go towards its destination path. You see this huge sort of yoke of arrivals coming into Heathrow and turning around and going down the path. You see the two other runways the other side. But it's very nice visualizing this volume that's up there that you would know. And it's also obviously very useful if you're interested in what noise is going to be coming from the sky. It's a very good map of where it's coming from.
So I rest my case that raw data can be sexy. I think I don't want to hit John Brockman's session. Do we have time for one question? Because we're an open source kind of group here. Okay, we've got lots more to talk about, but wisdom is in the crowd. Anybody want to put a question? There should be a microphone somewhere roving around. If not...
So what we saw here, these are visualizations of physical systems, and I'm wondering whether you or anybody else whom you know dealt with the visualizations of abstract data, conceptual data.
There's a lot of work in that field going on. We do some. I don't have any here, but there's a lot of work done where it's sort of mapping abstract things to a sort of a geographical plane or volume, and then running some of these techniques. And if you've seen them, there are things where a sort of a story is mapped into a line, and then paths and connections between different stories and forwards references and backward references are drawn as lines, and you get these very beautiful things. Or time travel in films that involves sort of time travel paradoxes, you can visualize that sort of stuff. But a lot of it is just using similar techniques, but mapping an abstract concept into a geographical sort of space.
Some of the most exciting examples, if you want to go to one place to see, there's a London-based visualizer called Stephanie Posavec, who's mapped the structure of Charles Darwin's Origin of Species as it went into different editions. So there are people visualizing the creative world as well as the physical world, and it's about the surprising and beautiful approaches they're taking to convey that information. Last question?
When you see all of these things, I know this is a personal question, but do you have some metaphor there it comes. When you're mapping all of these things and looking at these things, do you have some metaphor with which, when you zoom out from it all, what are you tiling? How do you understand the whole that you are slowly visualizing? Or do you have some metaphor you use to understand it in the abstract wholeness of the thing? Is there something like that?
What do you call it? I call it information.
I have a vision of what I want to make, of what these things should look like in the end. This one was very much about creating sort of what looked like plumes of fire across the planet. Not so much beyond that. It's mainly, the goal with this was to create, this one in particular was to create an image of this structure that was there that you couldn't see, you couldn't really perceive it in reality, but it is up there. That's as far as it went.
Is that art or nature that you're mapping?
Well, it's man-made construction.
I think Hal turns it into art.
I think I turned it into art. I'd like to think the pilots weren't being artistic at the time they were doing it.
So can I just thank Hal for this extraordinary set of presentations.
Thank you.